In section 2.4, we're going to try and get familiar and comfortable with the graphs of the sine and cosine functions. So we want to graph y equals cosine of theta and y equals sine of theta. As kind of like a first approach, we're going to look at the value of the sine and cosine function at some very special angles, multiples of 90 degrees. We're going to look at that in radians. Since cosine is the x-coordinate of your points on the unit circle, you can find these coordinates by looking at the unit circle and running through all the x-coordinates. So starting at 0, cosine of 0 is going to be 1, cosine of 90 is going to be 0, and then cosine of pi is going to be -1, then back to 0, and then back to 1, completing your trip around the unit circle. So 1, 0, -1, 0, and 1. Likewise, for sine, you're going to look at the y-coordinates of your points on the unit circle. I'm not going to repeat that. We're just going to look at those numbers. That's going to be 0, 1, 0, -1, and 0. Now, when you graph these in coordinate pairs, this is your x, and that's your y-coordinate, we can get the graph of the cosine function. So the graph of the cosine function is going to look like this. At 0, the function starts up at 1. And it's important to understand and see that the function does not start at 0, 0. That makes it different than the sine function. So 0, 0, it's going to be 0, 1. At pi over 2, which is roughly here, the cosine is 0, then down to -1, back up to 0, and finally returns to 1. Now this process is going to repeat itself. And you're going to have a wave shape as you look out the x-axis and look at this graph. Similar to that is the sine function. In fact, these two graphs are just shifted versions of each other. But when we look at the sine function, we have a different xy pair. Here's your x, and this column is now your y. So the important thing with the sine function, as I mentioned, is that it starts at 0. So you get the sine of 0 is 0. Sine of pi over 2 is 1. Then at pi, you're back to 0, then -1, and finally up at 2 pi, you're back at 0. And this function, again, is going to repeat itself. You can see it off to the left, and if I could extend it to the right, it would also repeat off to the right. So those are your two basic graphs. Now the analysis that we're going to do next works whether you're dealing with the sine or the cosine function. So we'll start by looking at the sine function. And what we're going to do is adjust the number that's in front of the sine. So we'll look at sine of 2 times the sine of x, half times sine of x, maybe even minus sine of x. I'm going to cheat a little bit and do it this way. So I've got the sine function in here in Desmos. And let's look at putting in different values here. So as I increase that number, what's happening to the sine function? Yeah. You're changing the range, you're changing the height. And let me give you a term that we're going to use here in trigonometry. We're changing the amplitude. Okay? So the amplitude is just the distance from this center line to the top. So when the function has a coefficient of 3, for instance, like 3 sine of theta, then notice that the amplitude, instead of going from -1 to 1, now you're going from -3 all the way up to 3. The amplitude, though, is half of that height. So the amplitude here is just that coefficient. It's 3. So back to our handout, the conclusion, and you can have different words for it, but the conclusion you should have regarding this coefficient is that A controls the amplitude. And the amplitude is just going to be the absolute value of A, which will be the absolute value of that coefficient. That's how tall this function is going to be. You can see it. Over here, when you have 2 sine of x, the height goes up to 2. And that height there, the distance from the center line, that's your amplitude. For the next one, well, that one's not so tall, is it? But that's because the amplitude's been reduced to 1/2. What happened with the negative here? What did that negative do to the graph of the sine function? It flipped it. But what's the coefficient here? The coefficient's, well, it's -1, but its amplitude, if you take a look at the absolute value of -1, the absolute value is 1. It has the same amplitude as our original function. It's just been flipped around the x-axis, but its amplitude is still 1. So that's one conclusion that we got. Are we okay with our conclusion regarding the amplitude? Let's play around with the next parameter, and that is, let's put something, in front of the x as the argument. So the argument is what you're taking the sine of. You always have to take the sine of something. You can't just have sin by itself. So let me shut this one off and turn this one on. And let's go back down here to 1. So that's where we start. I'll put a 1 in front of there, so sine of x. But as I change this, if I move up to, say, 2 or 3, what's happening to the graph? The frequency. How fast it goes up and down is going to change. Now for your sine function, the regular sine function, let me get rid of this for a second. How far is it between these two peaks? How long before the graph of the sine function repeats itself? Does anyone know? So you got a point here at 0. Is the function repeating itself in this interval? No. How about over to here? Yes. So that distance is 2 pi. That's how long it takes the sine function to repeat itself. Every 2 pi, the function is going to come back to where you started, because that's once around the unit circle. You can see that in the other direction. Let me kind of zoom out a little bit on this. So you go 2 pi to the right, and you're back where you started, heading up from 0, 0. Or in this case, heading up from y equals 0. What that coefficient does here is it increases, or it changes that frequency. It changes how often you go up and down, or changes your frequency, the period. So let's move that up and down again. And what happens is that b, that number in front there, divides the period. So let's talk about that. Let me go back here. B controls the frequency. So the period of a regular sine function is 2 times pi. The period, how long it takes to, for the graph to repeat itself in our new function is going to be this. The period of this graph is 2 pi divided by b. So that divides the period. So the bigger it is, the shorter the period. And the shorter the period, the more often it's going to go up and down. It's going to increase the frequency. The frequency is the reciprocal of the period.
So basically, Jeff, if the number is multiplied by the function, then it messes up, or it has something to do with how high up and down the function goes.
Right.
And if it's inside the parentheses, then it has something to do with the frequency of the function.
Exactly. So
it stretches it out or it compresses it.
This coefficient talks about the height or the amplitude, and this one talks about how often it goes up and down. Okay. Notice the height in all of these is stuck at 1. Let's take a look at this one in particular. I've got a 1/2 here. If I take 2 pi, which is the frequency of my sine function, and divide it by a 1/2, when you invert and multiply to simplify this, how is it going to simplify? What will I get? 4 pi. So I don't quite have room for all that here, but if I did, then I would take a distance of 4 pi before this thing starts to repeat itself. So this number divides the period. How about over here? What's the period of this function going to be? 2 pi over 2, or just pi. And you can see that. After a distance of pi, this is pi right here, the function starts to repeat itself. This one's even better. A little bit clearer to see. Well, it would be if you could see these numbers very well. What's the period here? Anyone? 2 pi over pi, which is 2. So every 2 units, 1, 2, the function repeats itself. 1, 2, function repeats itself. So that number divides the period. Now there's one last effect that we're going to see. We're not going to use it too much, but I will demonstrate it a little bit here. And that is, what happens if I subtract something or add something? Now I'm looking at this in kind of a limited case when I've got a coefficient of 1 in front of my x. But let's see what happens to this point when I compare this graph to x minus pi over 2. Where does that point get shifted? Well, it got shifted over here to pi over 2. If I have x plus pi over 2, then again, I have that point that got shifted. This time it's been shifted over here to negative pi over 2. And so what happens is that this value of c controls things in terms of a horizontal shift. Horizontal shift. And we don't need the second part of this, or the last part of this, just yet. I think we're going to be able to work okay with just the first two parameters and work with sine and cosine. But on the back of this handout is a lot about how we're going to finish up. So this is going to save us an immense amount of writing. An immense amount. Well, the good thing, I mean, you might look at it, there's a few people are looking at it like, OMG, you know, and then you have fear in your hearts. Really, all we're going to do is try and do some matching. That's all this is trying to do some matching. So let's first of all go across the top row and determine a few things about these functions. First thing we want to determine is, are we looking at a sine function or a cosine function? So let's start with the first one. It's a cosine function. Why is it a cosine function? Doesn't start at 0. So this is a cosine of something. All right? Cosine of something. And what about the number in front? What can I put in front there? A 2, right? Because its amplitude has to be 2. All right. So we're well on our way. That eliminates a lot of choices down here, doesn't it? It's not a sine. It's not something that has a coefficient of 3. So that eliminates a lot of choices here for us. Now there's one last thing that I got to figure out, and that is the period here. How long before this graph repeats itself? Yeah, twice as long as usual. So the period here, this distance, is 4 pi. That's how long it takes for the graph to repeat itself. We okay with that? You see that the graph starts out at 0, 2, goes down and back up. It gets back up to 2, a distance of 4 pi later. So that's telling me that 4 pi is my period. 4 pi, well, that's going to equal 2 pi. Oops, thank you. 2 pi over b. Because remember, the value of b divides the period. So how do I solve for b? Well, basically, these things got to switch. Yeah, b is going to be 1/2. But let me show all the details, the gory details in that. if you're trying to solve for b, you can multiply both sides by b and get b times 4 pi equals 2 pi. Because when you multiply both sides by b, you're going to get the cancellation there. Now we're interested in solving for b, so I'll divide both sides by 4 pi. What's 2 pi divided by 4 pi? 1/2. So this is 2 cosine of 1/2 x. Which one does that line up with? 23? All right. My apologies. I did one of your homeworks. It's all right. I know. So what did we do? We did a couple things. First of all, we determined sine or cosine. And it was a cosine because it started away from the origin. Then we determined the amplitude. That one was pretty easy. And finally, we determined the period was 4 pi, and that led us to the conclusion that this coefficient was 1/2. And then we nailed it. We had our function. Let's repeat that over here. I'll pause for a second if there's something that's still not quite clear to you about this one. All right, Rebecca, let's look at part B here. Is this going to be a sine or cosine function, do you think? That's going to be a sine function. Good, because it starts at 0. That's a sine function. Good, thank you. Shamir, what number can I write out in front here? Well, let's take a look at the height here. What's the height of these waves? Do you agree that the height here is 2? So that's also going to be this right here. So 2 sine of theta. So worst comes to worst, I mean, you've already eliminated a lot of choices. I mean, if this was, some kind of a multiple choice test, then you really cut down a lot on your choices. There's one last thing I need to determine, and that is the period here. Yeah, it's going to be the same as the last one, right? This distance, where the graph starts to repeat itself, is again 4 pi. I don't think I need to go through this again. What's that make b equal to? 1/2.
Jeff, where do you start with the period? How do you determine this is the beginning, this is the end?
You just have to find identical points on the wave. So, for instance, this point would be pi, and this point would be, well, that's 2 pi, 3 pi, 4 pi, that's 5 pi. So if you go from top here to top here, 5 pi minus pi, it's still 4 pi, right? So the period is the distance between that you have to travel to get to identical parts on the wave. And it doesn't matter if you do it here to here, here to here, or even here to here. If you do 3 pi minus negative pi, you're still going to get a distance of 4 pi for the period. So, thank you. Let's move over and take a look at this one, and then I'll have you try a couple. Part C. Jamel, do you think this is going to be a sine or cosine function? It's going to be a cosine. It's not a sine because it doesn't start at 0, 0. So this is a cosine function. Cosine. Charbel, what do you think the coefficient is going to be that I'm going to put out here? -2. Good. Notice it's a -2. It's -2 because you're not starting up here. You've been reflected down to here. So we've got a -2 out in front. And I think we're back to familiar territory at this point, right? What's the period of this one? Period's 4 pi, so that puts us at a 1/2 out in front. They're not all going to be 1/2. But there's your function. Y equals -2 cosine of 1/2 x. All right. Why don't you try a couple? Why don't you try, let's see. Why don't you try H and I? So we'll mix them up a little bit. Try H and I. Start out by determining sine or cosine, determine the amplitude, then determine the period, determine the Okay, so first things first, you want to determine sine or cosine. Which one is this one? That one's going to be a sine function. What's the coefficient? Well, what's the amplitude here? Amplitude is 3, but because it starts down, it's going to be a negative 3. Next thing we need to determine is the period. How long before the graph repeats itself? Pi. Distance from here to here is pi. So if I set it up, pi is 2 pi over b. When I solve, multiply both sides by b, divide by pi, I get b equals 2. Now, if you can solve this faster, that's great. What you need to come up with is that b is 2. So that overall, we've got y equals negative 3x, negative 3 sine of 2x. And that's your graph. What's one way you could check it if you're like, I'm just not really sure about that? How could you check it? graph it with your graphing calculator. Here's exactly what you would do. Type in the function, -3 sine of 2x. Make sure your calculator is in radian modes. Let me clear out this one. Let's go between 0 and, say, pi, right? And then hit zoom 0. Let your calculator adjust the window in the y direction, and it's looking pretty good. Nailed it. The graph repeats itself exactly once in that interval. All right, let's finish up with part I. Which function is this, a sine or cosine? Cosine. And I think you're probably pretty comfortable with the number out in front, right? That's going to be a 3. And the period is like before, it's pi, so that's going to be a 2x. So y equals 3 cosine of 2x. And there we have it. I mean, these functions are great. You can tailor these to a lot of different phenomena. There's a lot of things that have periodic in nature, the orbit of the moon, the number of hours of daylight, etc. There's tons of things. Yes, sir? If it's inverted, it's going to start out heading down as opposed to heading up. So it's a great question. All right, for cosine is going to start out at a peak and then go down. Sine is going to start out here and go up unless it's been flipped. So yeah, sine starts out going down when it's been flipped, and if it hasn't been flipped, then it starts out going up. Cosine starts out going down in the regular case, and when it's been flipped, it starts out by going up. All right? So, great question. Thanks for that. Let me give you some homework. For homework, try problems 11 through 45.
Odds and even?
Let's just do the evens because I'm a nice guy. So, all right. So, homework. No, all right. Do the odds. 11 through 45 odds. That's section 2.4. Have a great week. See ya.